It seems like there's a lot of pictures of asteroids these days that don't make a lot of sense. I know I'm an unwashed woo master without the grueling mathematics necessary to be allowed into the mainstream puzzle factory, but maybe someone can help me out and explain how this asteroid walked away from an impact that left this crater on it without getting blown into space dust. If the vaunted experts are correct and cratering comes from collisions, this was the equivalent of a Mack truck plowing into a golf cart at 150 miles per hour, and the golf cart continuing on to the next hole. Even better, a lot of these guys have been hit multiple times by similar impacts, not to mention countless smaller ones. Now out here in Realville, a collision like that would have turned this rock into a pile of dancing atoms. But not in the Big Bang multiverse, where literally anything can happen with enough funding and imagination.
Okay, this segment he has two logical fallacies. One's the fallacy from incredulity, which means he can't understand how the asteroids can stay together even after impacts. This argument, but the thing is, asteroids are made of different materials and different compositions, and some are more porous, so they could probably take a hit better than the others. And the other one is the argument from absurdum, which means he takes things to an absurd level. Like if this doesn't happen, if an asteroid doesn't get blown to pieces, therefore the Big Bang's faults. Plus, then he goes into the typical, I find typical argument from a lot of cranks is, well, you don't take my argument seriously, you don't give me millions of dollars to do research. Research funds are actually quite scarce, and they have to be spread along a large number of projects. So it's hard to get it. They also use this for Halton Arp, because Halton Arp didn't get telescope time, but if he couldn't write a proposal to prove what he was doing was valid, the telescope owners have a right not to let him use the telescope. Plus, the Electric Universe spent $10 million. Here's Wal Thornhill.
Changing the decay rate of radioactive waste and doing it the way nature does it, which is nuclear chemistry. And nuclear chemistry uses catalysts. So the design of the experiment, my contribution was the subatomic and the atomic nature of the sun and what's going on in that plasma. And that was verified, which is wonderful. So we've done, for $10 million, we've done what all these other people have been trying to do by forcing nature to behave the way they expect it to mathematically. First of all, you've got to know what you're talking about before you can have a mathematical model and trust it.
Wal Thornhill and his group had the Sapphire Project, which was a project to try to prove that the sun generated electricity, generated heat through electricity, and the details of the project weren't released scientifically or how it was done, so it's not really considered a valid scientific project. That's where $10 million went.
The experts say the story of asteroids all began way back in the murky depths of our primordial past, where they accreted out of neutral gas, kabillions of years ago. Accreting is when little rocks and dust in the early solar system smashed into each other at ludicrous speed. Then, for reasons I do not understand, supposedly all stuck together and got bigger until they became asteroids.
Okay. Why they didn't obliterate into multiple different pieces is because when they hit each other, they generate a little bit of heat, and the particles were actually dust grains. And dust grains, in an astronomical sense, are like a silicon base with a lot of ice on the outside, so the outside ice melted a little bit, and they fused together. Or when bigger pieces together, like rock, hit each other, they melted and they fused together. They just had enough energy to do so. That's what happened.
Unlike planets, who kept on accreting until they were planets, asteroids did not. and the experts suspect it could have something to do with the gravitational influence of the emerging gas giant Jupiter, but it's just a guess. Now, because of the assumed interrupted history of asteroids, a lot of experts believe they must therefore keep a pristine record of what things were like in the early solar system, much like comets, who the experts view as being made out of the primordial ice that comes from the legendary but cleverly hidden Oort cloud, way out deep in the solar system, where we conveniently have no way to verify its actual existence. I'm sure it's there.
The Oort cloud, you can't detect it because a lot of the objects are really small and therefore not bright enough to be detected. But we have long period comets that are 15,000 or 17,000 years long, and the only way they can exist is from being that far out in the outer solar system. Jupiter deflecting comets and stuff, that's been detected several times, and it's actually broken up comets like the Shoemaker-Levy 9 in 1994. Well, it happened a couple of years before 1994, but it collided in the planet in 1994. So it has been detected. It's not a guess. It's only a guess in their view.
The standard model of comet formation is a wild guess, and now that we keep landing on them and can't seem to find all that water and ice they dreamed up, we know it wasn't a particularly accurate guess. Well, everyone makes mistakes, though generally we're supposed to update when experimental data blows our theories out of the water. One undeniable fact is that recent photographs of these bodies pose severe challenges to popular ideas about them. Asteroids don't have a lot of gravitational oomph compared to planets and moons, and most of the stuff traveling in their neighborhood is going in the same direction. Without the gravity to bring in stuff hot, and with very few rocks going against traffic, it's pretty hard to imagine the standard impact theory being possible, especially when it requires high-speed collisions in the thousands of miles per hour to happen. And after these rocks formed, one might ask, where did they get all those craters? They're covered in them. Countless small circular craters, and almost always a few that look like they should have been planet killers. But in fact, they've all got them. It's a common feature of asteroids, and that's a little confusing to me. Even more confusing is the fact that all these craters are at a perfect 90-degree angle, almost as if an electric arc had run across the surface. But Mr. Narrator, that would be insane. What are you, some kind of crackpot? Clearly, the rational answer is that trillions of asteroid impacts on them all happen to strike at an exact 90-degree angle. Well,
many of these objects have been around for about 4.5 billion years. That gives you enough time to gather up a lot of conclusions. Plus, the early solar system was filled with a lot more smaller objects than today, so a lot of them are now part of those asteroids. About comets, some of them do have like a rocky surface, but there has been spectroscopy of water detected coming from them, so there is water there, and some of it may be hidden underneath the surface of the comets, but that's not a complete wild guess because this guy doesn't understand it. Nope, your incredulity has not been lost on anybody. There's plenty of asteroids that are objects in the solar system that have craters that come in at angles, and it doesn't require air. I don't know why you think it needs air bursts to have objects coming in at an angle. Even in Saginaw Bay in Michigan, there's a impact crater that came in on the side, and Berger crater in Arizona. So there's plenty of evidence of showing craters at angles, not just at 90 degrees. And them coming in at 90 degrees, that just happens. Well, you do need for large bodies like this, like the Earth or the Moon, gravity does pull it in perpendicular to the surface of the object, but better because they have more gravity. But you don't need gravity for it to chance to come in at 90 degrees to the surface.
So what does this confusing hodgepodge of comet and asteroid formation theory have in common? It's all wrong. Turns out, it's the electric model of space that can explain what we actually see. What need has the electric universe for rocks smashing into one another like drunken bumper cars when we believe the history of the universe is brimming with intense energetic events and violent electrical interactions between planets and moons? Just the sorts of things you'd expect to smash everything into rubble and throw it into space. The scars we see on planets, moons, and asteroids don't come from collisions. They come from electric arcs. These arcs have the ability to cut surface depressions, to scoop out material, and to accelerate it into space, leaving behind cleanly cut geological relief in perfectly circular craters. How do we know? Because we use electric arcs to do exactly this every day in common electrical discharge machining, EDM. Unlike the mathematical nonsense the experts pretend is real, we know how EDM machines work, and we know the electrical machining effects they produce is scalable, probably infinitely scalable. In the photograph here of the asteroid Ida, the right side exhibits sharply cut gouges that altered the fundamental shape of the body. The same asteroid showed a depression on its westward termination almost as wide as its diameter. Could impacts have achieved these things while leaving no other evidence of disturbance? Well, this is where I put my hand up. No, teacher, they could not have done that.
Well, there is evidence on Earth that there are rocky bodies at the bottom of craters, such as a meteor crater. I believe they found iron there and iron around the rim. And there's the Sudbury crater in Sudbury, Ontario, which is a large nickel crater meter that people have been mining for years. That's why there's a nickel mine there. So, yes, there is evidence that there's been impacts from meteors. I don't see any real evidence of electrical arcs. Okay, I think that'll be it for today. I hope some people found this enjoyable or educational. But yeah, just don't like these crackpots that much. I hope everybody has a good day and have a good one. Bye.